So over the last week, we've talked about scale factor, and we've talked about dilation. So let's review what a dilation is. When something becomes larger or smaller, right? And what's scale factor? Okay, so the thing you multiply by, can we use a different word other than thing? The what? The ratio. So the ratio that we would multiply or divide by, that would change our figure, right? It would get larger or smaller based on that ratio. In IM1, you talked about congruency. What does it mean for something to be congruent? Equal in every aspect, right? 100%. It is 100% equal. Similar, on the other hand, is going to change. And we'll get more into it in the next unit or the second half of this unit. But if figures are similar, everything's the same except their size. That's where the dilation comes in, right? So if we look at, for instance, if you look at the cones in number 1, we're going to prove that they're similar. We're going to look at scale factor. But you can obviously tell that one is larger than the other, right? Okay, so similar solids. Two solids with equal ratios of corresponding linear measures. So we're going to measure and make sure everything's similar with the radius or the height or the length and the width. We'll look at all of that and find a scale factor. But the size, yeah, now it's crooked. Okay, but the size will change. One will be larger than the other, okay? Scale factor, we talked about a common ratio of linear measurements for a pair of similar solids. So just another fancy definition, but that's our ratio. And how do we set up that ratio for scale factor? How do we set up the ratio for scale factor? Image over pre-image. And image is which one of your figures? The one that changed, the new one, right? The one with the primes. Your pre-image is your original one. Okay? So if two solids are similar, meaning their scale factors are the same, all the corresponding side lengths have the same ratio A to B. So if they're similar, when we set up a ratio comparing all of the different measurements, the ratios will be the same if they are similar. If we come up with a ratio that's not the same, they're not similar. I was saying. So if we compare everything and we set up our ratio, okay, image over pre-image, and find a scale factor, if they're all the same between all the different measurements, the figures are similar. If one of them is different, the figures are not similar. Are you okay with that? Okay. I'm going to skip this and part for a second, and we're going to look at number 1. So determine or decide whether the two solids are similar. If so, find the scale factor, and we're going to go left to right. So the left figure, we're going to just call our pre-image. The right figure, we're going to call our image. And then we'll talk about ratio of volumes in a second. So scale factor first. So image over pre-image. What can I compare? What two sides would I theoretically be able to compare? What would match up? The what? The diameters? Okay, so the diameters we should be able to compare. So if we compare the diameters, we're going to go image over pre-image, so 126 over 54. Right? Now, with all fractions, what do we have to do? Simplify them. So let's see if we can come up with a number that goes into 126 and 54. Let's think about 54. There's not very many options. Or not as many options, maybe as 126.
27.
Huh?
27.
27? You want to see if 27 works? Okay, so does 27 go into 54? This is where your calculator comes in handy. Yeah? Does 27 go into 126? No, not as a full number. Okay, so here's my concern if we just start picking numbers, random numbers too. You're going to be like, I can't find anything and it doesn't reduce. Okay, so we should probably start at 2 and kind of work our way up. Oh, and they're still throwing out random numbers. Okay, hold on. Listen to what I just said again. Some of you know it's 18, if that's what you're saying it is. The problem with just guessing numbers is you may never find it if you don't guess properly. So if you always start with the lowest number possible, you know you can continue to reduce. It may take you a few times, but you got there. Some of you have fancy calculators that will do it for you. Okay? And that's fine too. I'm going to show you, if you don't have a fancy calculator, how to do it, but we'll get there in 1 second. So I'm going to start at 2. We're going to do this first one kind of by hand, and then you can do your guessing. So if I start at 2, 126 divided by 2 gives me what?
63.
63. 54 divided by 2 gives me what?
27.
Okay, so that's now a little more manageable. When I look at that, I know a number that goes into both of those right off the top of my head. What's that number? 9. Right? 63 divided by 9 is... Okay. And 27 divided by 9 is 3. So those of you that said 18 were correct, right? I divided by 2 and then I divided by 9, which is 18. But my ratio is 7/3. Some of your calculators do that for you. Okay? Your fancy or your non-fancy calculator also does it for you. Do you want to see how it does it?
Sure.
Are you sure? Okay. So if you have this calculator, you're going to type in the numerator, so 126. Does everyone see the ABC button on their calculator?
Yeah.
It looks like a, mixed number.
Yeah.
Okay, so the ABC button. If you click the ABC button, it gives you a fraction. And then we're going to type in 54. Okay, and this is why I'm hesitant to show you. Here's what's going to happen. Ready?
Oh.
What does that mean? What does that mean? 2 1/3. Okay, if you can look at that and you know that means 2 1/3, great. But we still need a ratio. We need a comparison of two values. How do I convert a mixed number to an improper fraction? Multiply and then add, right? 2 times 3 is 6, plus 1 is 7. Keep the denominator. Okay, if you understand that button on your calculator, then use it. If you have no idea what I just did, you're going to have to just simplify as you go. Okay, I'm okay with either one. But on a test, like, I don't want you to come back and be like, what does this mean again? Like, if you don't know it, then I want you to do it the old school way. Okay, so we've compared. Wait, what did we compare first? What did y'all compare first? The radius? Okay, so if I compare the radius, so here's my pre-image, here's my image, I would have 60 over 100. You all know the trick where like the zeros cancel out?
Yep.
So 6 over 10 reduces to what? 3/5? Okay, so that's my first ratio for the radius. Now I need to do the height. 45 over 90. What does that reduce to? 1/2. And look what happens when I plug this into my calculator. 45 ABC 90. So if your numerator is smaller than your denominator, it will give you a nice reduced fraction. If your numerator is larger than your denominator, that's when you're going to get that mixed number. Okay? So 45 over 90 reduces to 1/2. And someone said, but they're not the same. How do we have two different scale factors? We don't. What does this mean if they're not the same? They're not similar. Are we okay with that? Okay. We'll come back to these in a second. Let's talk about ratio of volumes. So when we're talking about just the side length, so if we found the perimeter of something, okay, so ignore this for a second. If we found the perimeter of something, what are our units? So if I told you to find the perimeter of the classroom, what would my units be? let's say it was feet. It was 5 feet and 10 feet and 5 feet and 10 feet. What would my final units be? Feet, right? Just feet. What if I said I want the area of the room? What would my units be? Squared. What if I want the volume of the room? Cubed, right? Feet cubed. So here is my scale factor. My ratio is just those side lengths. When I'm finding ratio of volumes, I'm going to cube my scale factor. So for this one, when they're similar, we're going to take our scale factor and cube it. This gives us our ratio of volumes, which means if I knew what the volumes of both of these figures were, I'm finding this scale factor for those volumes. So ratio of volumes, I'm going to take my scale factor and I'm going to cube it. What is 7 cubed? What is 7 to the third? 343. What is 3 to the third? 27. Okay, so this is the ratio of volumes. This is scale factor. Ratio of volumes and scale factor. In the case of number 2, they're not similar, so do I have a scale factor? No. So do you think I'm going to have a ratio of volumes? No. Okay, so if figures are similar and if we have a scale factor, we can find a ratio of volumes. Okay, let's do number 3 all together and see what we can find. So let's compare. What should we compare? So here we're going to use this as our pre-image and our image. What do you want to compare? Anything?
749.
The 7 and 49. Okay, so 7 over 49 reduces to 1/7, right? Okay, what else can I compare? 8 and 56. What does that reduce to? 1/7. And what if I don't know that? Remember, I can do 8 ABC over 56, and it gives me 1/7. Because the scale factor is the same, these two figures are similar. Because they're similar, I can find the ratio of volumes. So I'm going to take my scale factor and I'm going to cube it. What is 1 cubed? 1. What is 7 cubed? 343? Okay, so ratio of volumes, scale factor. Are we okay with that? Yeah? Number 4. Where would you start with number 4? The diameters, I heard? Yeah? Okay. So if this is my pre-image and this is my image, I would have 40 over 20. And what does that reduce to? 2. I'm going to put 2 over 1 just because we're talking about scale factor. Anything else to compare? So what do you think we're going to say about whether or not the spheres are similar? They are or they are not? Take a second and talk with your group and come up with a why. Why are they similar or why are they not similar? Who can give me something? Do they think these spheres are similar or not, and why? Anyone? Haley.
I don't think there's one because you don't have enough information to find out. You have a very small portion of information.
Okay, so they're maybe not similar because there's not enough information. All right, any other thoughts? Darian?
They are similar because they have the same scale factor.
Okay, they're similar because they have the same scale factor. What else? No other groups talked about anything? Everyone said the same thing? They're similar? Why are they similar? They have the same scale factor? Okay. So in 1 through 3, I had scale factors to compare, right? Like I looked at the diameter and one of the side lengths. I looked at the radius and the height. I had 2 things to compare. Do I have anything to compare here? No? Does that change anyone's opinion? Okay, by a show of hands, how many people think that these 2 figures are similar? 4 or 5. So everyone else is going not similar. How many people are like, I have no idea? Okay, I have a couple people as well. So here is a trick or a hint that you should probably write on your paper. All spheres are always similar. All spheres are always similar. Because the only thing that really changes is the radius of the sphere. Okay, so all spheres are always similar. So you know going in that the sphere is similar. You just have to figure out what the scale factor is. Can you take a second to find out the ratio of volumes? Okay, find the ratio of volumes. I wish I could like write on this so I could like move.
I'm okay.
Ratio of volumes. What did you get for 2 cubed? 8, and then 1 cubed? 1. So my scale factor is 2 over 1. My ratio of volumes is 8 over 1. So there's a lot of parts to that. Is any of the math really super difficult? No, but you have to understand what it's asking you, right? So determine if they're similar, so you compare all the sides that they give you, all the pieces they give you. If the scale factors are the same across the board, you know they're similar, and then you can find your ratio of volumes. Say you had 4 or 5 different things you were comparing. As soon as you find 2 that don't match, it's not similar. You don't have to keep going. Does that make sense? Okay. Are we okay on the top part? All right. So let's look at example number 2. The solids below are similar. So I'm telling you straight off the bat, they're similar. Given the volume of the solids, find the ratio of volumes and the scale factor from left to right. So we're still going to say this is our pre-image and this is our image. So what am I currently given? Volume, right? I want to find ratio of volumes. So what does that mean? What do I need to write? A ratio. And how do we write ratios? Image over pre-image. So can I do 8 over 8,000? Now, with all ratios, what do we have to do? We have to simplify. I think this would be a really good one to plug into my calculator. And what do we get?
1 over 1,000.
1 over 1,000. Some of you probably saw that, right? You knew 8 went into it. So my ratio of volumes, this is my ratio of volumes, is 1 over 1,000. So that's our first step. Find the ratio of volumes. Make a ratio with the volumes. Simplify. Ratio of volumes. Does that make sense? Okay. The second part says to find the scale factor. Any guesses on how I can go from ratio of volumes to scale factor? You do the thing with the 3. So you don't divide by 3, but you do the thing with the 3. I think I heard it from a couple people. Cube root it. So what did we do here to go from scale factor to how about I point to one you can see? What did we do here to go from scale factor to ratio of volumes? We cube it. What's opposite of cubing? Cube root. So like when we square something, isn't the opposite square root? So 3 squared is 9. If I wanted to know what the square root of 9 was, don't I take this, like, if I want to know, that doesn't make sense. Like, my words don't make sense. But do you see what I'm saying? So square root and cube, or square root and square are opposite of each other. So cube would be opposite of the cube root. Cube would be opposite of the cube root. And guess what? Your calculator is going to do all the work for you. Ready? Everyone have their calculator? Okay. So in your calculator, do you see the button that has this X root on it?
Yeah.
Okay. So if we're taking the cube root, we're going to type in 3 because that's what's being replaced with that X. And then for me, I'm going to hit second and then that button. So I get that 3 root. That's going to be the cube root. And now I'm just going to plug in my number. The cube root of 1 is 1, right? Because 1 times 1 times 1 is 1. And we'll go backwards so you can see it. So the cube root of 1 is 1. We're going to do the same thing with 1,000. 3, second X root button. And then we're going to type in 1,000. What do you get when you hit that? 10. Okay, so does that make sense? If I went backwards, what's 1 to the third power? 1. What's 10 to the third power? 1,000. This is my scale factor. So I just worked backwards. Up here I started with scale factor. I cubed it to get ratio of volumes. Here I have ratio of volumes, so I'm going to take the cube root to get scale factor. Yes? No? Maybe? So? Yes? Okay, I want you to try number 2. You and your group, try number 2. Okay, so image over pre-image. So 1792 over 3500. You can do that by hand, or we can plug in 1792. We hit our ABC button, 3500, and you get 64 over 125. The calculator gives you the simplest form. You don't have to look any further. Okay, so this is 64 over 125. And what did I actually just find? Ratio of volumes. Okay, so I found the ratio of volumes. What do I need to find? Scale factor. And how do I find scale factor? Cube root. So in my calculator, let me show you. I'm going to go 3 for me. A couple of you are different. So the cube root of 64 should have given you, whoops, I don't want that parenthesis. Should have given you 4. Did you get 4? Yes? And I know what this cube root of 125 is. But if you plug it into your calculator, what should you have gotten? 5. How could I check my work to make sure that those are the right numbers? Cube them, right? 4 times 4 times 4 gives me 64. 5 times 5 times 5 gives me 125. So none of this math is difficult, but if you plug something in wrong, it might mess you up. If you're not doing image over pre-image properly, it might mess you up. So you just want to make sure you kind of double check yourself. Okay? Questions? Comments? Concerns? We're good? Okay.